right, so it's 7:05, so we're going to get started. Again, we have these recordings prepared, and so we're going to be in the chat. Everyone who's giving talks tonight, or today, is going to be in the chat, and it's going to be available to answer questions in real time about what's going on the screen.
Hey everybody, I'm Ryland, and I'm the product person for Temporal. I'm really happy that we have this opportunity to do our second open office hours. When we went into the first open office hours, we weren't really sure if it was going to be something that was successful and that people actually got value from. And so it was really great to get all the feedback from you over the last couple months, and understand that it really was something that brought people value, and that there were some changes that could be made to the actual format, so it was even more valuable. But in general, people really liked it, and so we did make some changes to the format. I'm going to start by giving just this little intro, and then there will actually be 3 structured sessions given by 3 different members of the team about different temporal topics, and then we'll use the remaining time for that free-form Q&A format, which we did for too much of the time last time. And so we have decided to keep everyone's mics muted just because there's been recently some attacks against similar meetups and stuff like this, and we just feel that the risk isn't worth it. We can just all use Zoom chat at any time, just chat, ask a question. A lot of these talks are recorded, so that way we can be in the chat with you answering questions about our talk in real time. We saw that people were talking about that on Twitter, and we thought that was a really great idea. So please feel free to use Zoom chat. We're there. We'll be moderating it. And so just to kind of give you an idea what you're in store for tonight, we have Manu presenting how temporal scale tests temporal. So you have the Leonardo DiCaprio Inception vibe definitely going on. It's riveting. I highly recommend it. And then next you have Vitaly, who is talking about temporal config and what value you can actually get out of the config that you might not know about, and what are the best practices and how should you effectively use it. And I think this is something that there's probably more forum questions about this one topic than anything else, because it's just Vitaly doesn't have 8 hours tonight to cover everything that you would need to cover in just the config. So he's really kind of reduced it down to the important stuff. And then we have Max. He's going to be talking about common pitfalls in temporal and how to avoid them, and in very much his style. It's a pretty free form session, and so he's going to be kind of taking your feedback and listening to what you have to hear and answering your questions. And then of course we are going to have this free-form Q&A with the remaining time, so that'll be a time explicitly for you guys to ask questions about anything temporal related. The only caveat being, if it's something very specific, we might break it off into a different room. We've had quite a few additions to the temporal team recently, so I kind of just want to introduce them to you guys because they're really awesome and they're really cool. So we have Derek. Derek has an infrastructure background, and he's really coming in to own the temporal cloud effort and really understand how we can do that. And so it's a pretty big undertaking. I think he's the right guy for the job. He has a very big picture but small detail approach, which is I think the exact skill set you need for a job like that. Next we have Coley. Coley's our information architect and technical writer, and he is responsible for kind of revamping our docs and all of our other written content. And I think anyone who's relied on our docs knows it's definitely got room for improvement. So I think Coley has his job cut out for him, but he has a very systematic approach, and so I think we're gonna end up in the right place. And then we have Vitaly, and Vitaly, he was probably the fastest ramp up of any person in temporal history, just because he came from working on cadence at Uber, and so he immediately had the right skill set, so to speak. And I think outside of being just a really good programmer, a really good developer, I think one of the things I've already appreciated about Vitaly is that he's allergic to frustrating problems. The things that would normally just go unfixed for a while, like he's not going to let those things go. And I think it really keeps like the healthiness of the company up. So yeah, Vitali's awesome. And then we have Manu. And you know, Manu was actually working at Uber, not on Cadence, but he had worked with Smar in the past. And he was working at Uber on more of an application level. And he does have a background in, you know, those low-level distributed systems, but he has that recent, you know, end user experience of building applications. And so I think he looks at building backends differently than, you know, the majority of people that I've worked with. And I think it's like a refreshing take. So, you know, he's already had and he's also just a really good generalist. He can get things done across the board. So yeah, he's awesome. We really appreciate having him. And then we have Carl, who honestly might have the hardest job at Temporal. He's responsible for finding more great people like that are on this slide. And, you know, we do try to keep a pretty high bar in terms of, you know, the caliber of people that we recruit and, you know, the type of people that we recruit. And so, you know, he really has his work cut out for him. But, you know, I think he has a very methodical and like direct approach to these things, and he's way more technical than most recruiters you'll meet. And so I think in general, you know, he's going to get it done. Now there's one thing you're confident he's going to get it done. So yeah, and you know, if you've ever thought about working at Temporal or what it would be like, this is your guy. Like Carl's your guy. You got to talk to him. Carl at temporal.io. And so I just want to talk a little bit about what we're doing right now, what internally we're focused on. And so right now, almost all of our cycles are going towards the stabilization effort. You know, we're really excited about the cloud, but right now we're 100% dedicated to getting V1 out. And I promise you, we want it just as much as you guys. And so the thing is, we're not going to compromise on quality. We're not going to make, you know, we're not going to put anything out that we're not proud of, but we are very dedicated to moving as fast as we can while maintaining those standards. And so, you know, we're not taking it lightly. Don't have any other updates, but we're not taking it lightly. And then, you know, it's not the best kept secret that we are exploring this cloud offering. This is something that, you know, we're now in like the serious design stages of. We're not actually doing any work on it yet. But it's something that we're taking it very seriously. And so it's going to be a while before we have something that's generally available. But we are looking for some initial design partners that are going to be able to, you know, they're going to be the first users of the system. They're going to have a direct channel of feedback and support from us. And so, you know, these are people that we're really looking to partner with. And I've reached out to some people individually. I plan on reaching out to everyone. It's just, you know, a matter of time. And so if I haven't reached out to you and this is something that sounds interesting, please let me know. And I'd love to have a discussion about it. So without further ado, I'm going to pass it off to Manu, who is our first speaker, and he's going to talk about how Temporal scale tests Temporal.
So yeah, I am going to pass it on to Manu. The one thing that I wanted to mention is that we're thinking we're going to give some time actually, like after each of the sessions, so people can actually have a time to chat just about that session, and you know the speaker can field questions, etc. So I'm going to pass it on to Manu. Manu, it's all yours.
Hey folks, can people hear me? Okay, great. Today we're going to talk about using Temporal to test Temporal and sort of how we can generalize this into using Temporal as a general stress test framework. So the agenda for this quick talk is, you know, what is the problem we're trying to solve? What is the right way to integrate some of these test workflows into the CI/CD pipeline? And then what are some of the common problems that when you use Temporal to stress test, how do you kind of deal with them, and what are some patterns to deal with those? So general motivation, what's the reason that we even looked at testing Temporal with Temporal? We know that Temporal is a core foundational service. So maintaining a high quality bar is important, right? People are running their core business logic on top of us. And quality requires more than just the functional unit testing that are pretty standard. So we have 4 different areas of testing that we want to use orchestrations to conduct. So stress testing, which ensures that temporal behaves correctly under extreme load. Performance testing, because we want to be able to come up with benchmarks that we can use to indicate how temporal performs against certain hardware, and from a build-to-build regression detection, if we make a change that causes a performance degradation, we want to be able to catch that immediately. And then finally, fault injection, because we want to ensure that temporal continues to function even when the underlying infrastructure has blips or failures, such as network failures, machine restarts, things like that. So we are using, as mentioned, we actually have a bunch of load drivers and test workflows that are written in Temporal itself that then exercise the Temporal server. So by doing this, we've been able to test drive Temporal in a critical real-world use case. We've been able to find a couple of usability and experience issues as we build this out. And of course, we get validation of both the Temporal server and the SDK as well when we use this to build out the tests. So even though we're talking about using Temporal to test Temporal, I want to make it a little more generic and talk about how you can use Temporal to generically test any cluster or system or product that you're trying to ship or release. So the general way that you can construct an orchestration to test something is there are 3 phases. The first phase is a driving phase, which kicks off workflows that will kind of apply load to the system. After that, and that can be multiple concurrent activities in a temporal workflow. And then the second phase is where you actually monitor or verify that the load was applied successfully and everything came up as needed. And then the final phase is when we actually do cleanup of the existing test artifacts so that the cluster is in a pristine state so that you can run another run of the test or a different scenario if you want to. And we'll go into a little more details here. So example of the driving phase is you may have an activity or a set of activities that places 100 million calls to your service API over the next 8 hours, right? Or you may want to spawn 100,000 long-running workflows where maybe each workflow represents, a customer on your platform. Or you may want to simulate burst load by scheduling, 100,000 workflows at once. Maybe you have a billing orchestration that runs at midnight, or a time-based thing where you have very little traffic and then a huge spike, and then it goes back to normal. So that would be the kind of logic you put into phase 1, or the first driving phase activities. Once you've applied the load and done everything through, then you have what is known as the validation phase, right? So depending on the drivers we had here, your monitoring phase may want to go and check that a certain number of API calls succeeded successfully for your test scenario, or that if you did spawn a large number of workflows, to go and check that all of those completed successfully. If your result of your test was you're expecting a database to be populated, you can use this to validate that there's data in there. And then of course you can archive these test results on a day-to-day basis so that you can look historically and see where you're trending and if there's any regressions there. And then finally, after you've applied the test load and verified that everything works, you want to make sure that you can sort of clean up any artifacts you created, any test data, any workflows that are still running, so that your environment is ready for a subsequent test run without being polluted by leaked artifacts previously. So the important thing with Temporal is that every change that we make basically goes through a pretty rigorous CI/CD pipeline. And as part of that CI/CD pipeline, we run a workflow with the 3 phases that I talked about earlier. So I'm just going to do a very quick run through of what that looks like from our end. So you have a CI/CD pipeline, and maybe we just landed a change to fix a bug or add a feature enhancement to the Temporal LAN server. So our pipeline will pick up the change, do a build and a deployment, and then it will basically, within the pipeline itself, it'll spawn a test workflow. So that spawning the test workflow happens from within the pipeline itself. Once that workflow executes, now we have a workflow that is executing on some workers we've deployed with the environment. And that is basically going to run the sequence of steps I outlined before. It's going to apply load to In our case, the service being tested is Temporal, but to whatever service you want to test if you're using Temporal as a test driver here. So it'll apply load. It'll then monitor the outcome of that load. Again, as we talked about, did the API call succeed? Did all the workflows complete? Things like that. It'll do cleanup afterwards so that the cluster or your service is clean for use afterwards. And then in the meantime, the CI/CD pipeline is waiting for that workflow to finish. And when that workflow is finished, then that step passes, and we know that now we can be green. So there are a couple of interesting problems here that we can go into, and some of the features that Temporal has that will make this easier. So one of the basic problems is that, okay, how do I even integrate this into a CI/CD pipeline? So we have a tool called TCTL, which we'll just refer to as the Temporal CLI, that provides a mechanism for this. And then alternatively, if you want to do everything via code, the SDK has similar, if actually more functionality than the Temporal CLI has for doing these kinds of operations. So as an example, within your CI/CD pipeline, this is an example of how we actually kick off and execute a workflow, which we call a sanity workflow that exercises a bunch of scenarios. And so you execute this, you can sort of see the output. It tells you the arguments that's passed to it, like the run ID, etc. And this command will actually wait until the workflow reaches a terminal state, whether it's completed, failed, canceled, timed out, and then actually prints the output there. So within your CI/CD job, you can actually just always run the same workflow. And if you've regressed something, then and your validation fails, or you're not able to apply a load properly, and that fails, you'll get a fail status, and you can just fail your pipeline at that point. And then similarly within our pipeline, in addition to executing that, we also output the results of the execution and even the workflow history of the build itself. This makes it very the workflow history of the stress run itself. This makes it very easy to, if it fails, we can quickly get a snapshot of what happened by just looking through the CI/CD logs in the UI. Or even if it passes, it's a good sanity check to see, well, did something suspicious happen, or was this looking weird even though it passed? So this is sort of an example of where we've used, this is a snapshot in the past of where we've sort of used this sort of test pipeline. And as you can see, a lot of these red cases are an example of like maybe a regression we had with one of our MySQL implementations, and it failed because as a result of that, the stress workflow kind of failed. Well, our workflow that validates those scenarios failed to run, and it was caught that way. So then the second issue that you'll run into is long-running driver activities, right? We talked about an activity that is going to potentially place millions of API calls over 8 hours. If that activity recycles or crashes, or the worker running it, just restarts, we don't want the activity to restart from zero and then again start trying to do 1 million API calls, even though we've already done 800,000 of them. Or conversely, what if your service that you're calling returns a temporary transient error that fails the activity, but you want to be able to sort of recover from that? So the answer is the activity heartbeat feature, which is very instrumental for doing long-running activities. The idea here is that when the activity starts, you can actually check any last heartbeat details that you've executed, and if it has, you can kind of rehydrate it to sort of a checkpoint variable, and this can be any kind of, I chose an integer here, but it can be any kind of struct or data type. And then based on that checkpoint, we can sort of resume where we were. So maybe we got through 500,000 calls and then we failed, and then the activity retried. We'll pick up the fact that we were at 500,000 because, as you can see, we're recording the heartbeat on each iteration. So we're updating how far we got, and we can kind of resume from there. So this is a way to checkpoint a long-running activity so that you can resume from where you were at that point. And then very quickly, this can ensure that if an activity crashes, we can resume from there. Recording a heartbeat also tells Temporal that the activity is still healthy and running so that it doesn't time out. And if people are interested, you can look at the heartbeat timeout options on the activity option when you schedule an activity. The third problem we have is dealing with a large number of workflows. So we have test scenarios which require us to spawn millions of workflows and ensure that they complete successfully. So doing that spawning and validation of them can be quite painful. So the answer here is a child workflow feature. Within a workflow, you can actually schedule a child workflow and wait for it to finish before you proceed forward. The benefits here is that canceling and terminating a parent workflow will kill all of its descendants. And similarly, if your parent workflow completes and your parent workflow is waiting on children, which are also then spawning children, if your parent workflow completes, you can be ensured that all your descendants completed as long as each one was waiting in the workflow for that workflow to actually, child workflow to finish. And very simple pictorial representation where we have a bunch of intermediate workflows that span out exponentially, and then the blue layer here represents that these are the final set of workflows that we're actually running. So then the last problem we want to touch over very quickly is aggregated monitoring. Maybe you've spawned thousands of workflows and you want to measure, well, how many times did this API get called from those test workflows? Or how many times was a particular process retried? So we can use the signal feature to have multiple workflows communicate to a centralized set of workflows whose sole responsibility is to process those signals and maybe update an internal counter or perform aggregation. And this is just a very quick example. We have this generic test workflow, and on each iteration, it has an update stats activity where all it's doing is sending stats to a central workflow. And that workflow is super simple. It literally just blocks for a signal. And when it gets it, it'll update state itself. And then your validation logic can simply just query that state to see, well, how many calls across all the workflows were successfully invoked. So that's about it. That's sort of just an overview on how we use stress workflows for Temporal, how you can use it to sort of test your generic feature, and some of the common features that Temporal has to address some of the common problems you'd have when you're doing a long-running stress workflow.
Awesome. Thank you, Manu. So I just want to give people like maybe 30 seconds or a minute, and if they have questions specifically about what Manu just presented, please put those in Zoom chat and we can answer them. But I'm just going to give like 30 seconds or a minute because we do have other things. So Mark asked, do you have some stats to share about the load on the underlying persistence layer? Manu, do you want to?
So we're still trying to formalize appropriate benchmark, and in order to report these, we do have some metrics in the Temporal server that indicates things like throughput, latency, especially when you're interacting with the persistence layer. Nothing that we're ready to publish yet, but that is something that at some point we will want to publish.
Awesome. Okay, so these no other questions have come in. I think we're going to move on. Vitaly, do you want me to share the video, or are you going to do that? Actually, so there is one other question. Vitaly messaged Slack while we're doing this. So we were trying to use existing temporal metrics, but trying to add custom tags. I don't know if that's directly related to what you presented, Manu, but.
There is a, yeah, so this is a good question. There is a discourse thread about adding, I think, custom tags to the Java SDK and reporting them. That's something that we're looking into right now, and we still need to look into deeper, so don't have an answer for that at this point in time.
Do you mind posting that thread, Manu? And
Yes,
I'm going to start sharing. So we're going to move on to Vitaly's presentation. He has prepared a video. All right.
Hello everyone, my name is Vitaly and I'm a software engineer at Temporal. Today I want to talk to you about a rather boring but at the same time very important topic of configuration. But before we jump right into it, let's make a step back and take a quick look at the high-level system architecture. This should help you understand what are the key components and what can be configured in the first place. One of the primary goals of Temporal is enabling developers to focus on business logic by providing a set of scalable primitives for authoring durable, stateful applications. On a high level, system consists of the client-side SDK, which provides a toolset for implementing durable multi-step processes that are often referenced as workflows. Workflow code may interact with other workflows or execute actions, known as activities. Each step of the client workflow is recorded on a server, forming workflow execution history. This state that is securely stored on the temporal server can later be used to restore every workflow on any client worker in case of a failure or after prolonged hibernation. Temporal server consists of a few components that, besides its core functionality, provide some advanced features such as workflow history archival, visibility, and replication. In order to function properly, all these interactions require a lot of configuration parameters, such as endpoints, ports, connection counts, concurrency levels, various timeouts, payload size limits, QPS limits, retry counts, jitters, etc. This is why we have a few hundreds of different config properties in Temporal. But luckily, most of this complexity is hidden, and as an end user, you would rarely need to ever touch most of these properties. However, in some cases, you may need to adjust certain settings, such as number of read-write partitions on your test queue, or add a custom index to your Elasticsearch. And in order to do that, I'm going to walk you through our configuration system and show you how those changes can be done. Now it's time for a demo, and I'm going to present my screen and explain how to make config changes depending on the environment where you run Temporal on. Alright, here I have a clean version of a Temporal master, and let's get into the Docker folder, which contains Docker Compose configurations and some startup scripts. I want to run Docker Compose up from this folder to start up Temporal server along with all of its dependencies. Let's explore Docker containers using Docker process command. We can see that Temporal server started here, and we can connect to it using the docker exec command. Now we can see that we are inside of the etc temporal folder, and if we type process command, we will see that Temporal server is running with the root of this folder. It also specifies that environment name is Docker. This environment name is used by the Temporal server to determine the name of config file to read. If you look inside of the config folder here, you would see that there is a Docker YAML file, which contains something that we call a static configuration. Let's open up this file and see what's inside. As you can see, there is configuration for persistence, all core services that are inside, some port numbers, file modes, and what's important is at the end there is a configuration to the path to dynamic config file. This dynamic config file can be used to change some properties of the system during a runtime. And poll interval here represents how often system looks for changes in this file. One of recent improvements that we made was making this dynamic config being mounted as a volume into your Docker container when you run Docker Compose, which means that if you go to your system and edit the config, dynamic config, let's say development YAML right here. These changes will be automatically propagated to the container. So there is no need to overwrite or change anything inside of the container itself. Let's modify, for example, the interval in seconds for the retry policy from 1 to 2. Save the file. Now we go back to the container. We can look into the dynamic config, and it is 2. So now it takes up to 1 minute for these changes to be picked up by the server, and they will be in use. Alright, let's get to the second part of our demo and run Temporal in the cloud. We provide Helm charts configuration to make it easy to run Temporal on top of Kubernetes. In terms of application configuration, we have a template in templates folder, which is called server config map, and it defines a bunch of properties that are needed for the application startup. Primarily, it configures data sources and key ports for communication between server components. It also defines the location of the dynamic config, which in this case comes from the YAML file under values, dynamic config YAML. You can provide any custom overrides here, and they will be picked up when you will start your Helm cluster. We can explore one node in a cluster, as I have already running Kubernetes here, and connect to one backend machine. As you can see, all this looks pretty similar to what we've seen with the Docker Compose. And we also have Docker YAML file here. At this time it's generated by Helm. We run also at the same etc temporal folder as the environment Docker. The only difference is the dynamic config, which in the case of Helm cannot be simply mounted as the volume because we run on a remote machine, and it needs to be provided by Helm at the time of startup. Let's modify dynamic config properties and see how we can push them to Kubernetes cluster. Since we already have the template config here in a values folder, let's just use that to override number of partitions from default value 4 to 5. In order to do this, we can run Helm upgrade command and provide a custom values file with the dynamic config. If you run this command and go back to our Kubernetes cluster browser, we can see that containers will be picking up this new configuration. Once the upgrade finishes, we'll have this file fully available in the cluster, and within 10 seconds servers will pick up these changes and make them available. Yeah, so this is how you run Temporal on top of Kubernetes, and this is how you change configuration. Let's go to the last part of our presentation and talk about future plans. So in terms of future plans, we are thinking about various improvements, and some of them are definitely providing better documentation about all our configuration properties, because it's pretty difficult at this point for users to understand what can be changed in the system. We want to make that very easy to understand and accessible. We want to enable zero downtime config changes using CLI and potentially APIs so that users can interact with dynamic config uniformly on different types of environments, be that Kubernetes or local run using Docker Compose or something else. We also want to provide alternative config sources such as Git or S3 to make it easy to share configs. Another idea is to support synchronous config updates with streaming response to the user, which would remove this part of eventual consistency and make it clear when the update has finished. Another feature that we are thinking of is adding versioning to all config changes, which should allow us to roll back any bad changes if they occur. And the last idea that we had was to have a gradual rollout and auto rollback features for bad changes. So these are some things that we are thinking about of improving in future. If you have your ideas, feel free to contact us on the community website at community.temporal.io and or email me directly. Again, my name is Vitaly. It was a pleasure talking to you. If you want to find more information, please visit our website at www.temporal.io. Thank you.
Awesome presentation, Vitaly. So once again, I think we're just going to give like 30 seconds to a minute for people to ask questions about that presentation, and then we'll move on to Max's talk. Hey, so Robin asked, is there some way to verify that a dynamic config has been picked up? I've seen some log messages, but is there some other way to tell?
Yeah, right now, unfortunately, this is the only way looking at log messages. That's what I meant when I mentioned the synchronous update. That would be a way to basically see what system is doing and which workers have picked up the change. We want to add that in future.
Awesome. The next question, Kevin asked, I know you guys have the Helm charts for deploying in Kubernetes. Just wondering if you think at any point in the future you will document how to deploy in a high availability fashion to Elastic Container Service in AWS. Thank you. So we want to document a lot of these things like the common integrations and common deployment paths. I don't think we have anything specifically like planned for ECS right now for any of the documentation, especially for the HA stuff. But you know, like down the road, it's definitely something we're not opposed to, and I think it's also something where a community contribution would be great. And I do think there are already some users running in ECS. I'm not sure if it's in high availability, but just as a data point. And then Mark asked, are these future improvements planned for dynamic config only?
So there's another question from him. I've seen someone deploying it to ECS with success. Not sure. It's like, okay. Anyways, we view a config as a whole, and we want to have a good story for the config as a whole. We don't have a definite message on whether or not dynamic and static config will be separate forever. And we're definitely looking for different options there. We want to improve both. That's the answer.
Awesome. So since no other questions have come in, I'm just going to pass it off to Max, and he's going to talk about the common pitfalls in Temporal and how to solve them.
So let me share my screen. So this is pretty free-form session. I was trying to come up with some ways to kind of demonstrate different failure scenarios, and I found that if I can go pretty deep and it will take a lot of time. So I will just show some basic scenarios, but if you have some questions, ask them, and I can show you kind of maybe some alternatives. So I'll start from basic account transfer workflow, which I usually show during the presentations. And all it does, it just calls to operations on activities, withdraw and deposit. And it runs those activities in a separate worker. So we have activity worker, which creates instance of those activities and registers them. And then we have workflow worker, which registered only workflow implementation class and host them. And then we have a transfer requester class, which just goes and takes this account transfer workflow and calls transfer on it. Practically, we have these three components. And usually you collocate workflow and activity in a single process, but the actual requester or starter of the workflows usually lives in some other component. Maybe it's some web front, like web front end or some other service. So if you want to, like, let's just run, for example, this requester. I have a Docker. Just let me show you. I have a service running for Docker Compose. I did Docker Compose up, and this is practically it. And I have a lot of warnings, but all we see is that the transfer of money was requested from one account to another. That is kind of what we did. The question is, how do you look into the system? Because it's a distributed system, it usually has a bunch of these workers running somewhere, maybe in Kubernetes or some other machines, and how do you make sense out of that? So we have a few, like two main tools. We have CLI and we have UI. So CLI, TCTL, if we do workflow list, it will show all workflows which are closed, or if you want to open workflows, here's the workflow we just started. And the main two commands we use to look at the workflows are describe, a given workflow ID, it will give you some information about this workflow. And in this case, it shows that task queue name, which we use to dispatch tasks to this workflow, workflow ID, run ID. So workflow ID is business ID, unique ID, which you can assign, run ID assigned on every run automatically. And then if we have timeouts. So, and as right now in Temporal, we changed all timeouts for the workflow being optional. And right now we default them to 10 years because we found that it's pretty rare when you actually need to time out the workflow, because for all business level logic, you want to actually use timers inside of the workflow code. And in the future, we will just default to infinity. It was just technical decision to time out for like make it 10 years. It was simpler for now. And all we know is the workflow is running right now. Where is the status? It should be status of it somewhere. Yeah, status running. But if you want to get more information about workflow, we want to do show, oops. Which will give us history of the workflow. And in this case, we see only two events. Workflow execution started, which contains all the information about the workflow, input, and so on. And then we workflow task scheduled, and never picked up. And the reason it's not picked up is that workflow worker is not running. But how do we troubleshoot that? So one thing we can do, we can use TCTL to look at the task list. So there is, if we run help, we will see the commands available, and one of them is task queue. Actually, sorry, I thought task queues, but we renamed the task list to task queue in Temporal, but I still sometimes use the old name. And if we use TCTL task queue, we will see that it allows to describe. And we can just pass the name of task queue and we can take it from the and we see there is no poller for task queue account transfer. And there are two types of task queues, which can be a little bit confusing, but we have workflow task queues, which are listening for workflow tasks, which is workflow worker is using, and activity task queues. If you use activity task queue type, yeah, activity, it will also show there is no actually activity worker on that. And this is how you will find out that nobody is listening on that queue. You also can do that for the UI. So if we go to the UI, just a second. We will see that we have this workflow running. We will see the input of the workflow, all the information which describe call gives. And then we can go to the history and we see the same two events which I showed. And here you can just click on the account transfer queue name, and it will show you that there are no pollers, both activity and workflow task pollers on that task list. So let's run the worker. So if you go to the, I have it here, account transfer worker, and we run it. So it will start it, and we probably want to see what happened, how again we see where our workflow is stuck. So one command which is very handy is that you actually can do workflow stack trace, and we can go and just need ID of the workflow. Okay, let's use UI for that. So we have workflow ID. And here's the stack trace of the running workflow. And it works for both Java and Go, and it will show all the threads which in that workflow. You can get it in UI as well. So if you go to the stack trace, we will fix that. It's formatting is not, we broke formatting recently, but it's still the same stack trace in the UI for the workflow. So practically if you, in the summary tab, history tab, and then the stack trace tab, which contains the stack trace. And you can do, again, as I said, for UI. Reality is stack trace is just a query. You know that you can query workflows, and it's just built-in query, which is, I think, is named ___ stack. And it's built into the SDK. So we know that our workflow is stuck on the withdraw operation, and we can click and see that it's exactly the line 35. So it looks like our workflow is running, but it's stuck on the withdraw operation. So how do we troubleshoot the what's going on, why it's stuck there? So we can go back and do the describe again. Not task queue, but the workflow. And what's changed now, we see the pending activities. This is very important to understand, is that if you go to the, this is something which sometimes is hard to troubleshoot. The describe call is usually very helpful there. In UI, its summary view shows that as well. For example, you always want to look at pending activities in the summary view, and it shows the status of those activities. Two main things to watch for is number of attempts. It shows how many times activity was retried, and the state. So in this case, it's scheduled, means that it was created, but it never was picked up by a worker because it's just one attempt and it's scheduled. So as we saw, we can go back to the in the history. We will see that activity task scheduled, the last event in the history. And if you click on the account transfer queue, we will see that there is queue for the workflow, but there is no queue for the activity. So this way you kind of know, okay, my workers which pull through this activity queue are not running or cannot reach the the system. So now we know why they're doing that, because we didn't run them yet. So just let's go and run the activity worker. Where is it? Here. Oh, it's a requester. I just asked for another workflow to start. Let's just run directly here. Count activity worker. Okay, it's up and running, and it's failing. Okay, it's failing because I put simulated exception there. If you look here, I just asked it to throw exception, but let's pretend we don't know about it. And let's say this worker it's a log of the worker, and usually if it runs somewhere else, you don't want to start looking at the log first. You obviously want to have access to that, but how do you troubleshoot it from the command line? So if we go back and run describe command again, we see that in pending activities, we see number of attempts changed to 7. So now we know that our activity failed 7 times. We know the actual information about the exception. In this case, we know that it was application failure and it was simulated. And we have the stack trace. So we know what where it's exactly failing. So we can go and look and, okay, here's the line of code which throws the exception. So we have information about that particular activity. What can be confusing is that if you go to the workflow, for example, and look at the pending activity, one thing is that it looks like our UI doesn't show stack trace yet. But CLI does, and we are going to fix that. But again, if something missing in UI, we recommend going to TCTL because it's more feature rich yet. And other thing which is important to see is number of attempts. But the confusing part, which always confuses people, even I get like initially got confused with that we don't write activity started and failed event in the history, because we want to allow activity keep spinning forever if on the failure, because we practically don't put any limit on number of retries. So it's okay to retry for months. But what it means, we don't want to grow the history, and because of that, we don't write activity task started and completed or failed every time activity fails. So if you see history with activity task scheduled and never picked up, it doesn't mean that your workers are done. Especially if you click on the task list and you see that activity is there. So you see the one important thing is you see actual identity of the worker, which usually is will be PID and host name. But you can override the identity for the worker options. And you see that activity is running. And at the same time, you see that last event in the history is activity task scheduled. Don't panic. Go and check the summary or describe call. This click, we are fixing that. Look and see if it's in pending activities, an attempt is more than one, activity is clearly failing, and you see the failure type. And this is where it is. And this is something to get used to, but always start from describe call. So let me go back to the, oh. So let's run describe again, and we see now it's 9 attempts. Yeah, it was 7, now it's 9, and again the latest failure is there. So let's fix our activity code. Okay, redeploy, which is easy in our case, and now it should go through with the next retry. Yeah, we see that actually both operations went through, and if you go run describe again, we will not see any pending activities. And if we go to the and if you run show, we will see all our workflow. And then only after it completed, we will write activity task started, which will include number of attempts. This is how you know that activity was failing. And now we also record the last failure, which caused the attempts. But I think the most important thing is to see number of attempts. One thing which did change in Temporal from Cadence is we start attempt from 1. In Cadence, attempt was starting from 0. So it means that attempt 1 means there's no retries. So 9 times, it means it was executed 9 times. So it was 8 retries. That is different from Cadence, because in Cadence, attempts start from 0. We kind of found that it was not intuitive to start attempts from 0. So they now start from 1. So yeah, if you have any questions about this, you can put them into the chat. I'm watching that. So other common problem which people are facing is timeouts. So let's put some sleep into the withdraw operation. Let's say I don't know. Let's say 2 minutes. Restart our worker. And request transfer again.
Max, somebody asked, what is retry interval? Is it dynamic, exponential, or how is it? It was a ATP.
That is a very good question. I'll cover that. Yes, it's important. Actually, let's do that. Yeah, let's revert this change, and I'll just show it. I don't think we need to run that. So practically, if you look at the workflow implementation, one thing we changed in Temporal, because we found that people expect automatic retries. And in Temporal and in Cadence, if you don't specify retry policy when you configure activity, it will not be retried. So activities execute only once. In Temporal, any activity gets a default retry policy. So practically in this case, if you look, options don't contain any retry policy here. And we provide the default one. The way you want to see the values of default policy is easy. You go to the, oops, let me show in UI, it's probably will be faster, easier to understand. So if you go into the history and look at the activity task scheduled event, it contains all information about scheduling activities. And part of that information is retry policy. So in this case, we see the default retry policy given to the activity is initial interval 1 second, backoff coefficient of 2, which is exponential backoff. So practically if it's a 1, then it will be a 2, then it will be 4, and so on. And maximum interval is actually 10x the initial interval. So 100, I think 100x initial interval, which will be 100 seconds, which is minute 40 seconds. And no limit on maximum attempts. And the limit, one other change we did in Temporal over Cadence is there is no expiration in retry policy. We use activity scheduled to close timeout for expiration. So practically, scheduled to close timeout is defines how many times activity can be retried. And so it's exponential. And the default exponential coefficient is 2. But you absolutely can configure all of that when you write an activity. So practically, if I take these options, I can say set retry options. And then there are a bunch of options which you can provide. So all of those I showed can be varied. For example, if you don't want a retry activity, you will say set maximum attempts to 1. This is how we disable retries. So that is one thing. Or if you want to change your backoff coefficient to 1.2, for example, if you think 2 is too aggressive. Another important one is maximum interval, because you want to make sure that like expansion backoff grows usually very, very fast. So that's why you want to make sure that you don't go into the end, your retries don't end up like every 4 months, for example. That's why I recommend having maximum interval always if you specify your own default retry. I think it will default to 100x the initial, but if it's not good enough, you can always specify, okay, I don't want to retry more than like every 10 minutes, for example. So this is how you would specify your own retry policy. Does it answer your question? Okay, let me read the other questions. Do you have any plans to show activity retries in the UI? So we plan actually to redo the whole UI experience, and we absolutely understand that if I need to spend the presentation to explain you how it works, it's already broken. We absolutely want to make sure that if something is failing, it is in your face and it's very clear the reason for the failure. Yes, we absolutely want to go and expose that in a much nicer way. We don't think we will add them to the history the way, just because we don't want to grow history. So we just need to come up with the right way to present existing information in the UI that it's pretty clear that something is failing.
And Antoine, I've tracked that specific request, so we're going to be keeping an eye on it.
We absolutely believe that current UI is very, very rudimentary, and we want something which is much more, especially when you're doing development and troubleshooting. We need to give you much more to, like much more fine-grained tooling that we have right now. So one thing I also want to show you is just about timeouts. So if you, as I said, I put, how much time do you have around?
So I think you have at least another 10 minutes. You can push it to 15 if you really need.
Yeah, let me show you that. So let's put this slip back into the activity I put there. I don't remember if I restarted it, but let's restart again. And let's request the transfer. Okay, we request the transfer, and let's look at our workflow in the UI. So we have this activity. You see now a state is started. So we know it's running and attempt number 1. And if you go to stack trace, we see that it's blocked on the not very readable, but we'll find it. No. Okay, I'm too lazy to look at here. Let's do the stack trace. What's the workflow ID? Yeah, so it's blocked on the on withdraw. So interesting. It didn't recompile. But okay, but doesn't matter. But it's blocked on withdraw. So it looks like we have more than one worker running. This is another thing which I get confused sometimes during debugging. For example, sometimes IntelliJ doesn't kill processes very well, and you end up with 2 workers running. And then it's confusing. A worker which you are not watching in your screen picks up the task. And if you don't expect that, especially if this worker has old implementation of the activity, it can be confusing. Usually you troubleshoot those things by looking into the history. So one thing which is important to understand, history contains identity. Practically every event in the history contains identity. So practically this is the process, and usually if it wasn't like distributed system, it would be identification of that process which started the workflow. This is the process which completed this, for example, workflow task. And then if you go to the summary, which is now not very well working. Okay, this workflow completed, probably timed out. No? Oh, because I had 2 minutes, it's passed. But if you go to the pending activities, they will show, let me start a new one. Here we will see the identity of the worker which picked it up, and for some reason it's empty here, but I remember it was showing before. I think I need to double check why it's not showing here. but it certainly should show in the CLI. So one thing I want to show, if I kill this activity implementation, then a lot of people and restart it. People expect that this activity will be restarted automatically because it has retry policy. The problem is that if you look at this activity, scheduled parameters, it has start to close timeout with 24 hours. What it means that activity will be retried in 24 hours because we don't automatically fail activities if worker fails. You might implement that feature in the future, but it's not there yet. So we only rely on activity timeouts to retry them or fail them. So be very careful when you choose these timeouts. So in this case, you probably need to wait 24 hours for activity to fail and be retried on the different worker. Obviously, you're not completely lost in this case. You can go and run a fail activity from CLI or from your machine if you need to, but there is activity command. So you can go and so tctl activity fail. So you can fail a complete activity from the CLI. I'm not going to do that here. It will take a long time to type the command correctly. But basic idea, if you specified wrong timeout for your activity and it's stuck waiting for long timeout, you still can fail that activity, and if it has associated retry policy, it will be retried. But choose the start to close timeout wisely. It should be as it should be long enough for the kind of activities don't fail if they are still running, and but short enough for a retry. If activity time is unpredictable or activity can run long time, use heartbeat. So heartbeat is a feature which allows you to have short heartbeat timeout, and activity will heartbeat periodically. And if the worker fails, it will practically restart as soon as the heartbeat timeout happens. So point is look at the and there are let me just recap that because it can be confusing. We have 4 timeouts. So scheduled to close timeout is the overall timeout for activity execution, which includes all the retries. So it means that if you say specified 10 hours, an activity can take 5 seconds, but it retries, it will stop retrying after 10 hours. Schedule to start timeout, how long the activity can stay in the task queue before it picked up by the worker. We don't retry this because retrying this timeout would mean taking it out of the queue, putting it back in the same queue. So we don't, in the most cases, unless you do task route in the specific host, this timeout doesn't make sense to specify because you want this timeout be very long because usually activity still makes sense even after long outages. But just think hard before specifying this timeout to consult with us. And start to close timeout is the most important timeout, is how long a specific execution of activity can take. And this is, if it takes, let's say up to a minute, specify it 1 minute. And then it will be a fail after timeout after 1 minute. And heartbeat 1 is maximum time between successful heartbeats. Let me read the questions.
Yeah, there's one question from Vignesh, and he said, I have a use case to perform a set of actions. Should we go for child workflow having several activities or activities defined as part of the main workflow? Question is more on the retry configuration, as we will be able to configure the similar use cases for individual activities under the main workflow.
I see. So right now it's not perfect. I want to do some improvements here, but basic idea would be that you in Java, in Go, you override it per context, so it's easy. In Java, you have this stub which implements the interface to call activity. So for example, if you want a different retry policy for withdraw and deposit, what you would do, you would just create 2 stubs. You practically will just say something like this, right? And then you would call it, use different stub to call it, and then you can specify different options, right? You would probably just so that is a kind of basic idea, right? And then you can just go and say, okay, I want a different like retry policy here. Obviously, it's not ideal if you have a lot of activities. I want to be able to override that per call, but this syntax is not implemented yet. But for now, you just create multiple stubs. Does it answer your question?
And Vinesh, there we go. That's a general question. Does anyone have any more specific questions for Max's talk? I guess it doesn't matter too much because this is the last presentation. So I guess we can just kind of field the questions as they come. So Robbie asked, I have a use case to populate the custom metrics. Can we have a small session on the, okay, so this is a session. So yeah, anyone who has like session suggestions, I recommend putting them in the thread that we have on our community forums. I'll put a link in the Zoom chat. And then you guys can just add those. And actually 2 of the sessions that we did today are drawn from that list of suggestions that you guys made. So we definitely are reading that. Madhu had a question. Is there a default for scheduled to start timeout? Can it be disabled completely?
So there is a default, and default is practically workflow timeout. So I'm not sure what you mean by disable. So practically having a schedule to start timeout the same as workflow timeout, and workflow timeout defaults to 10 years. Right now, you can think it as default is 10 years. But in the future, we will remove the 10-year limit. It will be kind of infinite. But conceptually, you can think it as infinite default right now. Does it answer your question?
So it did. And the next general question, Vinesh said, can we have an independent workflow to send a signal to a temporal cron workflow?
So cron workflow technically is not very different from a normal workflow. So it can do anything normal workflow can do. So it means that you can send signals to temporal cron workflows. I think right now, if a workflow is waiting, it will keep waiting if it receives signal. But we probably need to kind of change that or make it a policy or specify which signals should wake it up. But yes, you absolutely can send signals to the temporal cron workflows.
Awesome. So guys, we have like a little under 15 minutes. If you have any questions, this is the time to ask them. Pretty much anything is fair game at this point, so don't be afraid.
And if you are new, one thing which, like while you're typing your questions, I want to show one more thing, which if you're new to the framework, let me go back to the activities implementation. Actually, we don't even need to do that. So let's say inside of the workflow code, I will go and just put workflow sleep. So let's say I sleep for 1 hour. And the question is, how do I test that? And we actually have a pretty decent unit testing framework. And I think that one of the core features of that framework is that it supports time skipping. For example, in this case, we test this workflow, but we mock activities. So there is we don't use real activity implementation. And then we validate these activities via code. And if I run this unit test, you see it's executed practically in very, very fast, like 1 second, but I think most of that was just startup time. And let me just see.
I think I'll answer a question from Antoine while you're working on that. So Antoine said, is there any feedback on using MySQL as a persistence visibility store on production? I'm particularly interested about challenges, choke points with this store, as there is this information in Cadence documentation about Cassandra. So I can give you like the high level answer, and then maybe other people can jump in and expand. So first of all, don't use Temporal in production yet. We don't have a production release. I have to say that I'm a product manager. And then, for MySQL, okay, so the situation is right now that there's no way to horizontally scale MySQL. Unfortunately, there's no like sharding story out of the box. And so it's just not an option when you have vanilla MySQL. So as of today, Cassandra is like the most supported database in that sense, where if you really do need to aggressively horizontally scale, that's where you need to go. What we are working on is support for Vitess, which allows you to actually, with a traditional MySQL setup, have the horizontal scaling. But this is not something that's ready or will be ready probably in V1. So that's kind of where we're at there.
But just to add about visibility, in general, visibility, because visibility will not be sharded anyway, especially for for Cassandra, if your scale is small, it's not a problem to run visibility on Cassandra or MySQL. But if you are planning to run tens of millions workflows or even millions of workflows in parallel or even over time, unfortunately, the indexing story is not good there, especially on Cassandra, and it can cause outages. So if you plan to run high throughput environment, we absolutely recommend you to use Elasticsearch integration. Without that, you can run into the issues. And as I understand, even with MySQL, we don't have very good, I think we didn't do very good tests yet about the large scale visibility stores on MySQL, so I cannot really comment on that, but I would be cautious there as well. Other thing is that a lot of features which are available only in Elasticsearch, like custom search attributes, they're not available in any other visibility stores. So one thing I want, just let me finish this demo. You see that I showed the duration of the unit test actually took 10 hours, like 1 hour, actually 1 hour, right? Why? Because I put 1 hour into the workflow sleep. And but one thing is, you see, I use test environment time, not system time. If I do system time, it will be milliseconds. But what a test environment does, every time it detects that there is a workflow is blocked, it will jump time ahead automatically. So it allows you to test workflows which take long time in milliseconds and without any additional effort. It just unit testing frameworks automatically take care of that. And again, so we had in our workflow code, we had sleep of 1 hour here, and I can change to 1 day, and this workflow will happily just show the duration of 1 day. And again, because our unit testing frameworks allow you to test long-running workflows, skipping time. So don't get confused by that as well, because people can expect sometimes that unit test will take longer, but it doesn't, because it skips time. And you always can see that through the test environment, current time milliseconds, and you can just measure time it took to produce that. Okay, going back to the questions.
So Paul asked, does activity scheduled to close reset on every attempt?
No, scheduled to close. It's actually a good question. Oh no, scheduled to close, not absolutely. I was thinking about scheduled to start. Scheduled to close is for all attempts together in Temporal. So practically, scheduled to close is the same as it was retry policy expiration time in Cadence. The problem is in Cadence, we had both scheduled to close and expiration time. And it means that if we would change expiration time, the scheduled to close automatically for you if you specify expiration time. It was kind of a mess. So in Temporal, we don't override any of those unless you didn't specify them at all. And scheduled to close is the overall timeout for all retries. And it doesn't change. It just, at the beginning, like first time you schedule activity, we will calculate the expiration time, and this expiration time doesn't change independently of the retries.
Awesome. So
there is one more thing I would add on that essentially is there is one way you can even change schedule to close timeout. That is by resetting your workflow.
Yeah, but that is, you probably they need to explain what reset means. Not everybody probably knows.
Yeah, so throughout the presentation, Max was showing, for instance, let's say if you have an activity which fails, or an activity which is the worker crashes and has a very long timeout of 1 hour. So one mechanism that Max showed during the presentation was you can, through the command line, fail that activity. So it gets retried. Otherwise, you have to wait 1 hour for the timeout to kick in before it gets retried again. Another way you can do similar thing is we have this feature where you can reset a workflow to any of the previous decisions or like previous workflow tasks which were completed during the execution. And the resetting of a workflow, essentially, it's like literally going back in time, picking a point in time where you feel the workflow is in a good state, and then you use the reset command to reset the workflow to that point. Once you do that, all the timers like workflow, timeout, and any other timers associated with different outstanding work also gets reset. So if you have an activity which is waiting for 1 hour, and let's say 30 minutes have already passed, so it will automatically reset that, schedule that activity with another 1 hour time period.
Awesome. So next question. So Madhu asked, need general guidance on upgrades rolling out of a new version of Temporal. Should this be my order upgrade Cassandra MySQL followed by upgrading Temporal server Helms followed by client SDK, Java SDK? And they said, i.e. Java SDK 0.28 should be compatible with Temporal 0.29 and Temporal Server 0.29 will be compatible with Temporal Schema version 0.30. And so to tell you the future story, we want to make everything backward. We plan on making everything, backwards compatible. And so I think a lot of this stuff will kind of become simpler. For the current situation, maybe Max, you want to comment on the best upgrade path?
Yeah, I can take that one. So, so before our version 28 release, we didn't have an upgrade story because we were asking everyone essentially that they will be wiping out the entire cluster and then deploying the new release version as a fresh install. After our code complete, now we have stopped making all breaking changes. So any forward versions of Temporal should be compatible with the previous version, which means that you have any existing workload which is running, you should be able to upgrade that cluster to newer version of the Temporal. There is one small caveat that I want to call out is we are still in stabilization. Although we do not have any planned breaking changes that we are aware of, but during stabilization, if we uncover a bug, which might require us to make a non-backwards compatible changes. But in the absence of that, you should still be able to upgrade, like apply a new version of Temporal server and able to deploy it on an existing one. So as you have pointed out in your comment, looks like you have answered your own comment also. The upgrade path is of course, all schema changes will be backward compatible. So you always, whenever you are deploying a new version, you always first deploy the schema, either Cassandra or MySQL. And then you do like a rolling restart and start applying the actual, the temporal server and just do a rolling restart and deploy the new version. We always make sure that if you have client, older client should be able to connect to newer version, and that should be backward compatible. So after schema and server is done, then you are free to update the client to the latest version also, which works with that server.
Yeah, but it's important to understand, new client might not to connect to the old server version. So you need to roll out the server first.
Awesome. So N asked, for local and CI/CD testing of an application with Temporal, do you recommend to only use unit tests with the testing package or run integration tests with the Temporal Docker container? And I can just answer this like a high level. You should always be probably running different types of tests. You probably don't want to just have unit tests. But if people have more specific information to add too.
I think unit tests are nice because they allow you skipping times. So you can actually, and you can allow, because you can mock activities and mock different parts for your workflow, you can actually provide a very good test coverage of all possible failure scenarios. And integration tests usually serve a little bit different purpose. And as they don't skip time, but they can be still very useful. So we recommend using Docker container for those, for integration tests.
One of the forms of testing, by the way, that people usually overlook is backwards compatible testing for your workflows. So we highly recommend like have some previous versions of your workflow histories also like stored, and you run those as unit test every time you are making changes to your workflow definitions.
Yeah, it relies on the feature that you can replay workflow code from the JSON files. So practically there is, I think it's in there. Yeah, so there is workflow replayer class in temporal testing. And this allows you practically replay workflow from resource or from just a file. And in this file, it's practically the file which you export in the UI or CLI. And it's also good for debugging in production. For example, you can just go to UI or CLI, download the history of any workflow, and then just call this replay method and run that in debugger as many times as you want. Or it can be part of the unit test for backwards compatibility. So Go has the same, I think, worker.replay method. Go has that as well.
All right, so Ashwani asked, regarding using temporal in production, what are the main pitfalls and when can we expect to confidently use temporal in production? So for the main pitfalls, that's like a session itself, probably not specific to production, but just using temporal. When can we expect it to use it in production is a question where I can't give you a hard time. We're just not doing that now. We think it's kind of for everyone's best interest. But we are in the stabilization period. We reached code completion, and so it is a matter of time. It's something that we are, again, putting all our cycles towards. So sorry, I can't give you anything concrete there. And then Paul asked, is it possible to reset workflows that have child workflows?
Not currently. We need to fix that. It's a known problem, and we need to fix that.
So we're tracking it.
And I think there is, by the way, another question, I think from Madhu. Once a workflow is submitted, can the options be changed? How does reset affect signals? So on that topic, when you say options be changed, I'm assuming things like retry options and stuff like that. So the way you do it is, today we do not allow options to be changed. It is actually a feature request. For example, change retry policy of workflow which is in flight. But today we do not have support for that. One way to do that is once again use reset, like make a code change where you are scheduling that activity and to change your retry policy and then reset before that change, before the activity was scheduled. So that is one way you can apply like change options for a workflow which is in flight. Your second question about signals, that is a very good observation. So what we do is, let's say if you reset a workflow to a point in the past, any signals which are in the history of that workflow, we scan the entire history and then basically put those signals in the new run, which is created after reset as new signals. So you will not lose the signals even in the case of reset.
It's even more complicated because we actually do that across multiple runs. Even if workflow called continue is new, and you did reset to some past, I think, run, we will find all signals in the after that and reapply them.
Yeah, so bottom line is we try our best to make sure none of the signals are lost, even in the case of reset.
Awesome. So we are a little over time, and I think the questions have kind of stopped. So I think this is a natural point to cut things off. I really appreciate everyone coming. Like, I think it was a pretty good session, and just the same as last time. If you have any feedback, like, if you felt like this format was less or good or better or whatever, please reach out to me, ryland at temporal.io. I'm on Slack, on the forums, and we just love to hear, input about, what worked and what didn't. And again, we really appreciate all of you being here.